Hello, everybody, and welcome back to week 3 and chapter 3 of our book, Discovering Computers 2018. I am Andy the Lolar, professor instructor, and this is my Theater of the Mind for computers in week 3. Okay, we are going to be talking about computers and mobile devices, including everything on this slide this week. So, taking a look, what is a mobile computer? Frankly, it's just a portable personal computer. We've said this a few times now. And it's designed so the user can easily carry it from place to place as opposed to a laptop or a server. Or a supercomputer, right? We'll go to extremes. So this is easy to go from location to location. So as we talk about it, mobile computers and desktops are not synonymous, though they do similar functions. As we discussed in Chapter 1, a computer is an electronic device operating under the control instructions in its own memory, right? So you start a program, the program puts the instructions into memory, and you're on your way. And now you give it input data. Then the computer processes that data using those instructions in memory, and you produce information data as output. So mobile device is a similar computing device, but now it fits in the palm of your hand as opposed to a desktop. So both of these, what they're doing is expanding our gamut from laptops to servers to ebooks to wearable devices, even including items with embedded computers in them, like your car. We'll talk about that in more detail here shortly. So a mobile computer really then is portable, which differentiates it from that desktop. So personal computers are often also differentiated by their operating systems, most of which are Windows operating system or Mac OS, which is really an Apple operating system. So an operating system is a software that supports the computer's basic functions, such as scheduling tasks, executing applications, controlling the peripherals like the mouse and the keyboard, etc. And you can see on the diagram on the right the placement of the OS in the order of things, right? You need your hardware, then you have this operating system that integrates those, how to use the mouse, the keyboard, those instructions as inputs. And then you apply the application, and then you yourself, the user, right? Now, a laptop is also called a notebook computer. It's thin, it's lightweight, it's mobile, and it has input devices and output storage devices, such as a hard drive. And it also has a built-in wireless communications capability normally. They almost all do built-in wireless communications capability. Then we have even things called ultra-thins. Ultra-thins have fewer input devices, such as ports, but usually have a longer battery life, right? Which is nice. We all want that most of the time. Now, to protect our OS, going back to that, you really do want to protect it, and there's a nice bit in the book in Secure IT 3-1 on page 3-3 that can be used for the course project. I highly recommend you look over that for that purpose. Also on your laptop, consider covering up your webcam when not using it, right? It's possible for bad actors, for hackers, to hack into your webcam and see what you're doing, to watch you. There have been cases, even recently in the last 2 months, of people hacking into a webcam and watching children play in their own bedroom. So you want to cover that up when not available. And you always want to make sure you have multi-factor authentication, known as MFA. Multi-factor authentication. Because that will keep a hacker from getting in. When you have single factor, one way of authenticating, a lot of times they can guess it. But when you have two, much harder, and that protects you with those sort of video camera capabilities, amongst others. Okay. So now a tablet is a thinner and lighter than a mobile computer. So we have this desktop, we have this mobile computer. Now we're talking about a tablet, right? And then there's a slate tablet that does not have a physical keyboard at all. It has, and then there's a convertible tablet that has a screen where its lid is really on a swivel hinge. Kind of cool. I don't have one of those, but I do have a slate tablet. I just call it a tablet. It's Microsoft Surface is my tablet, and with it, I like to use a stylus. So some will have a stylus. I had to buy it extra for it, but it's nice to have. So, you know, my big fingers have sometimes a hard time hitting these smaller tablet type objects, right, as an input. So I use a stylus, which I like, right, instead of a fingertip to enter the data, as opposed to clicking the mouse, for example, having to carry around a mouse around with me. In fact, here is a fun fact that I would like to share with you. A stylus really is plural styli or stylusis. Stylusis. It's a writing utensil or a small tool for some other form of marking or shaping, right? They even use it in pottery. It's been used there for ages. And it can also be here, in this case, a computer accessory that is used to assist us in navigating or providing more precision when using touchscreens. So there you go. And then the final thought here is there's a phablet, right? Beyond a tablet, there's a phablet. This is a smartphone with a tablet. So it's larger than smartphones, but smaller than full-size tablets. Okay? Some distinctions there which are interesting and help us navigate the language of computer science. Now, a handheld computer, such as the one shown here, also communicates wirelessly, but they are usually specific to some industrial work. You'll see these a lot of times. Workers will have them in Walmart checking stock and doing cargo pallet management in a warehouse, that sort of thing, right? For example, a simple barcode reader or barcode scanner, right? It's going to use this optical scanner that can read printed barcodes. It'll decode that data contained in the barcode and send it to a computer, right? Some would say even like a flatbed scanner. It consists of a light source, a lens, and a light sensor that's going to translate these optical input pulses into electrical signals. Additionally, nearly all barcode readers contain a decoder circuitry that can analyze the barcode's image and provided by the sensor and send that content to the scanner's output port. So kind of interesting, probably a little too much for this course, but interesting the way we use barcode scanners and other devices in our industrial work, these handheld computers. Now, a computer stick, sometimes referred to as a compute stick or a PC stick or a PC on a stick. I've even heard computer on a stick. And I think the book mentions a screenless PC, right? Here's a single board, palm-sized computer. This little thing that you're looking at is a palm-sized computer that somewhat resembles that media streaming stick, right? Like the Amazon Fire Stick or Google Chromecast or Roku has a streaming stick, I think. It's similar to an oversized USB flash drive, right? So it's really about the same size as a USB flash drive, and it'll ping into your plug into your HDMI port on the computer, and they can run an operating system and apps. It'll run your TV, right? Like a Roku. One drawback, of course, but it's okay for its purpose, is it's very limited storage. But for its purpose, I don't need storage, so I'm good with that. Okay. The desktop, right, is a personal computer designed, as it says on the slide, to be in a stationary location where all of its components fit on or under the desk or table. My first desktop, it all fit on top. Later versions had a tower which fit underneath, and then just my screen and keyboard were on top. So some people use the term system unit to refer to the case for the motherboard, right? So I put a picture of the motherboard on the right. That's the this is the printed circuit board containing all the main components of a computer or other device with connectors into which the circuit boards can be slotted. So motherboard there, like I said, is pictured on the right with all of its various features, inputs and outputs and other memory slots, CPU slots, battery, CMOS battery slot, Ethernet connection, etc. That's your motherboard. So the desktop is the main screen that you see after you turn on your computer and log into Windows, for example. Like the top of an actual desk, it serves as a surface for your work when you open programs or folders and they appear on the desktop. Many of you are probably using a desktop right now and looking at this video through that capability. Now then there's a tower I mentioned, which a tower houses the system unit on the desktop. Remember I said the system unit really refers to the case of the motherboard. So the tower is going to house all of that. And then we sometimes talk in terms of AIO, which means all-in-one. So there's kind of an all-in-one desktop. These don't have a tower. All of this system unit capability is not in a tower, but it's in the video portion itself. It's an all-in-one unit with the screen that will fit on top of your desk. So desktops are useful for users who don't require portability necessarily, and maybe they need more computing power, and a desktop's a little bigger. It's going to give you that. Gamers like a desktop, right, for that kind of computing power and screen definition. If it's a high-end desktop, it's sometimes called a workstation. That's the difference between a workstation and a desktop. Where I work, we all have workstations, we refer to them as, because they're all high-end computers. Interesting. Now, then we move on to another type of computer called a server. A server services other computers or network devices and will store content and control access to their hardware, their software, and other resources. A firewall is an example of a server that limits access to other systems unless you approve them by the rules you establish. A data loss prevention, or DLP, is another type of server that limits the movement of data around your network. The firewall and the DLP servers, they're dedicated servers to perform very specific tasks, either the firewall or data loss prevention. And so they require faster processors because you don't want, it's called latency in computer terms. You don't want delays. And the more the computer has to do, the more it's going to delay getting you the output that you asked for when you clicked and gave it input. So they require faster processors, more memory, additional storage, right? Servers may or may not require a monitor or an input device. Often the server activity is actually monitored through an application called a console. A console is really just a basic computer or monitor and keyboard that is connected to another computer, server, or mainframe on the network, right? And what you do with the console is you maintain or monitor the status of this network computer. So servers are placed here, are shown on the right. A rack is housed in a slot called a bay, and on a metal frame called a rack. So a rack server has a slot, which is a bay, on a metal frame, and that's called the rack. And a blade server is another type of server. A tower server is similar in size and shape to actually a desktop. So right there, I'm going to pause, and we'll come back to types of dedicated servers in part 2.